So if you're new to this, and I should mention this, if you look down below in the description under the YouTube video, if you're watching on YouTube, there's a section that has a bunch of links and stuff. So let me see, screen one. So that should be showing the right thing. So over here on screen one, this is actually the stuff in Slack where it's recreated. But if you look down under the video in the description down there, it'll have a thing that says index for lawn tractor automation meetings, and the one that's the HTM link is that's the preferred one. The text one is pretty cryptic. That's why I used to do it. But anyway, you can go look at that and find out either for this meeting, which is also on your YouTube at the bottom. It should show you the different chapters. So it'll link the current description of this video and the chapters. You can look at that there. But if you want to back up to see what we've done for the last 2 or 3 years, however long we've been doing this, you can go look at that index file, and it gives you a rundown on how that stuff works. So that's what you should look for down there if you're interested in seeing more of this stuff. So last week I was saying, in fact, for the last couple meetings, I was saying I got my wheel odometry installed on this vehicle back here. So if you could back up a couple of meetings, you can see where I've got that. The encoders bolted on, and no, I'm not going to try to show pictures of that. Anyway, I got those bolted on, and I just said, so one meeting I said I just need to tie those into a microcontroller so I can read the values, and then I need to write the software to generate the odometry statements. And I got around and did that and presented that, I think, like 2 meetings ago. And then the last meeting, I said I took that data and pulled it into Excel, and I showed a ground plot of what I was getting, and decided that it didn't look as square as I wanted it to. And I was pointing out that back in the old days, back in I found it in 2019, I was presenting the same type of thing with Excel for the ROS, or for the the ROS agriculture group when we were doing it back then. And I basically went through the steps and said, well, here it is in Excel. And then I showed the original plot, and next to that I showed the recreated plot. And then by changing a couple of numbers, I could change the shape of the output. So basically you're scaling the odometry by doing that. So I went back, and it took me a long time to remember how to run Excel, and I had to fight with Excel. But I finally got it running a couple of days ago, and I went and played with my numbers, and it 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 does change the shape, but I can't get it to look as square as I want it to. So I change a number, and so the whole thing is like a loop like this, and you can make it open or close. So say this point right here is my 0, 0, and then it's got like a rectangle I'm driving in, and to start with it goes maybe like this, some weird shape like that. As I start moving stuff, I can get it closer and closer to being square. But as I do that, then the lines out here, they're supposed to be straight, they starting to curve on me, and I might just be fundamentally missing something here. But anyway, I got it to that point, and I was looking at it last night and thought, well, I should create all the stuff for the meeting today. And I thought, no, I was tired and I didn't want to do that. So I'll try to whip up some stuff. And as Al says, I can post the picture on Slack, but it won't show up in this video unless I add it on. Maybe I can figure out how to edit it on later. But so anyway, that's kind of where I'm at. I've got to the point where I can do that in Excel now, and I can't pick a number that's going to work completely, I don't think. So I'll just have to play with that some more and see what I can make that do. Other than that, I guess a couple days ago I was ordering on Amazon, and it turns out this board that I'm using right now for the encoders, I was thinking it was a $5 board, but I just happened to be digging through, and I found 3 for $9. So I ordered 3 more of these at $3 a piece. And I'm not suggesting anybody gets these. I'm just saying that's what I'm using right now. And um, at the moment, I'm fairly happy with it, as opposed to, say, the blue pill board, which is, let me change my view. So the blue pill board it's got the STM 32F103 processor, and it does indeed work but it looked like the code space might be tight enough that I thought I'd just go to this next one, the next one that's got the bigger, it's got the STM32F401 processor. It has either 2 or 4 times as much flash space, depending which of the blue pill board you buy. And it's got more RAM. It's got 64K as opposed to 20K. But and you can buy these different ways. This one happens to have like this little micro dip switch on here, which is a real pain. Right now it's got plastic over it, but if you want to go through the whole boot thing where you're trying to do the Arduino or download it, uh, I, it's got going to build bootloader built into it from the factory, and then you can also, like on the blue pill, you can load somebody else's Arduino type bootloader on it, and I say this one's got the dip switches. Yeah, and I should turn my background off, but I'm too lazy to do that. So anyway, it's got the dip switches on, and you get another one has like 2 push buttons here and then a push button down here. And so it makes it, you don't have to screw around with those little tiny switches. And you could if you want to run the bootloader and all that stuff, you could do it that way. But since I'm running this this other thing you can buy on Amazon, it's the ST-Link debugger module, and you just plug it into it, and then I don't have to do anything with the switches or anything on it. If I just plug this into USB and go to my ID and say download, it does. And that, so I don't really care about the buttons and switches and all that stuff. So anyway, that's just a side point on that, you know, from a development standpoint, I'm just bypassing all that, the other nonsense, and I'm using the ST Micro IDE as opposed to Arduino. I didn't want to go down the Arduino path again at this point. So that's kind of where I'm at. As I just ordered 3 more boards because they seem to be $3 a piece, and it's handy to be able to sit here at my desk and program one of the processors, and then take the processor outside to my garage, pry the old one out, plug the new one in. That gives me the code, so I don't have to drag all my equipment out to the garage to try to reprogram the thing. So that was somewhat of an advantage, and I should just get everything loaded on a single laptop so I don't have to drag, you know, multiple laptops around or anything. So that's pretty much what I did this week. Was I got the stuff to work in Excel, and as I say, I'll try to post that, and maybe I'll just I could just go through and create a separate video, um, and just I can post it out on our channel and say these are my equations and formulas inside of Excel, so I can zoom in on each one. I can pause the thing, zoom in on the first one, and say run it again and say this is the formula to take the 16-bit encoder value that my processor gives me, and then I have to subtract that from the previous one, and that tells me number of counts per loop as I go through. So I'm running at 10. I think it's currently running at 10 times per second. So every 100 milliseconds, it says read up the current encoder and subtract the last encoder, and that gives me the delta, or the number of counts I moved in that 1/10 of a second. And then there's another equation that says now take that and sum that, or what's the next one? So the next one, I say convert that to a distance in meters, because I had this issue several meetings ago. I said I'm going to go through the whole thing, and it's kind of a mess. Part of it's in meters and part of it's in counts. I'm going to go through the whole thing and do the whole thing in counts all the way to the end, and then I'll convert it to meters, and, you know, distance in meters and speed in meters and angles and radians and rotational velocity and radians per second. But I got to looking at that stuff, and down at the very low level where I'm taking I'm trying to figure out how many counts it moved. No, it's the one of the next steps up, where after you figure out how many counts it is, in order to figure out your actual distance that you traveled, you take the left wheel plus the right wheel divided by 2, which gives you the average of those two, and that becomes your distance you traveled in this 1/10 of a second. I got to looking at that. If you do that in integer, say if you got left is 0 and right is 0, you add them together, you get 0. You divide that by 2, you still get 0. Well, if you have, say, one of them is a count of 1 and the other one's a count of 1, you add them together and you get a 2. So you divide that by 2 and you get 1. I think that's yeah, 2 divided by 2 should be 1. Anyway, whatever that is. But if you get the case, you got 1 is a count of 1 and 1 is a count of 2, now you get a total of 3, but you divide that by 2. Well, that's 1.5, and in integer you can't have a 1.5. So it's either going to round that up or round it down. It'll probably, say if you get 1.5 out of that, it's probably going to round it up. So every time you get an odd number, it's going to start accumulating extra counts. And I thought, well, the easiest way around that is what I'd originally done. I got it up to the point where I knew how many, how many counts the left wheel had gone, how many counts the right wheel had gone, and then immediately convert that into distance per, um, uh, uh, convert that into a distance in meters. And you just simply take the result of that and say divide it by counts per meter, which is something you have to calibrate. You have to calculate and calibrate that. And then once you get it into meters, now you're doing floating point calculations on the rest of the stuff. So I ended up going back to that, and that's probably where I'll leave it. And I need to go through several more times and say, do I need to clean up this section? And one thing I want to do is get the variable names so they make sense, because you're sitting down, you're hacking on this stuff, and especially if you spend work on it over months or years, your variable names keep changing, and they don't really mean what they're supposed to mean, and none of them seem to match. So anything that's in count should say counts in the variable name. Anything that's say in floating point distance, make sure it says distance in the name somewhere. So that I just need to go back and clean up stuff like that as I go back through the thing. So hopefully I can maybe by the next meeting I'll go through and say, here's all my C code, and then it probably won't have the cleaned up variables at that point, but I can just go through and say, so line for line is C, here's your functions that you have to do that, and then pull it up in Excel and say, okay, convert a line of C to an Excel function. This is how you do that. So I can go through and show those steps. And then I can show the actual recreated plot, and it says I change these numbers, you can see the shape of it change. And the whole point of doing that is I need to take some data from the robot. I need to go out and create a new data set. I've got new driveways, so I got flat driveways, and I need to go out. I need to actually walk behind it and make sure it's going straight. And then when I turn the corner, make sure it makes a nice 90-degree turn, and then drive down and do another 90-degree turn, and try to get straight lines and nice corners. So I've got a decent data set, so I know really what it was doing. Because when I ran the first one, I just wanted to see if it was working. I just sat on the ground and just drove it around like a radio control car. So I sat there and drove it down my sidewalk, and it wasn't going straight. And then I turned into the driveway where I couldn't really see it. And it's basically, as it drove around, I wasn't getting a high quality data set out of the thing, because that wasn't my intention up front. And then later I thought, boy, I wish I would have done that. So that's probably one of the next things I have to do is, pick some numbers to put in. I could use the same numbers I had the first time and go drive it around. So I visually, mechanically make sure the thing is driving straight and making nice corners. And then I can come back to my Excel and then go through and do my calculations and see if I can get the numbers. Because if I find the right numbers by doing it on Excel, I can go back to my C code and put those in as a scale factor, put those as a scale factor into the code. And then when I drive it, it'll come out, whatever my results were on Excel after I did all that stuff, then it should be generating those automatically on its own. And then you can still go back in Excel and tweak that if you want. And on a related note there, if I take my scale factors, I have it so I can put those in as a ROS parameter, that I can send those down to the code. Once you load up the node, you can send those down. And that way, if you later decide I want to tweak that a little bit, you go into your parameters, say, give it this number instead of whatever the default is. And that would be handy when you get to a calibration stage and you say, I'm going to go out on my sidewalk and I'm going to tell the thing to drive straight up the sidewalk, say for 100 meters or whatever number you want. And while you're doing that, you can take the heading out of GPS, and you can take the heading off your IMU and verify if you're going straight or not. And then you could then do some kind of calculation. So you compare that line, or basically that angle, if it's not going straight. So take whatever's coming out of odometry, which would create a curved line, and then take the other ones and say, okay, I could probably, by doing some mathematical function, figure out how to adjust that number, and then just go ahead and send it down to the odometry code, since I can now put if I put a point where I can change it with parameters, then to do a calibration, you drive up the sidewalk, do your calculation, and take the results, and then put that into the parameter and send that down to the odometry. And then hopefully it's going to say that it's driving much straighter than it was before. So that's just something I was thinking about, that I should do that. And I think Al has already done this, where you can set your initial position. So if I drive out to my test location on the corner of my sidewalks, and I've always called that 00, X0, Y0, and heading of 0. And so I could drive out there and just have set parameters. Just it forces those values, so it starts at a known location, or drive to some other point in the yard where I know where it is. Because I could drive anywhere I want and stop, and then I can read the XY values that's generated through the GPS. And since I got the dual GPS, I can get the high quality heading off that. So theoretically, I can take those numbers and shove that into the odometry at any point, just to lock everything together before I start driving on a test. So that's just more things I was thinking about that I may or may not do if I get around to it. And other than that, I guess so that's kind of where I'm at. Maybe for next meeting, I'll have whip up something that says, here's how I'm doing this stuff.
You mentioned earlier about programming and not having to drag stuff around to program it. Can you just talk a little bit about what is your workflow to, program and get it to work on the robot? Again, I'm just fascinated by that whole STM board and the cube thing and how you manage all that.
Well, I do use CubeMX IDE, I think they call it. So it's just a standalone program. You download it from ST Micro. You must give them an email address. They want to extort that out of you so they can send you advertising or whatever they're doing with it. So if you download that, put it on the computer, and then if you're starting a new project, you go up to the thing, it says create new project, and it says, oh, here, let me help you out. It says, what kind of board do you want to use? And you go to this big list, and they want to list all the eval boards from ST Micro. And so if you're using an actual ST Micro eval board, which I've got to hold one up, but here, I'll keep talking while oh, here's one right here. So what I started off with, this is one of the official eval boards from ST Micro, and it was called the F4 Discovery board, I think is what it was. And it turns out they don't sell this anymore. I think it sells something equivalent that just simply has a different processor chip on it there. But their eval boards comes with this processor, which is hooked to all these IO pins on the edge here. It's got like 100 IO pins on this board, and then over here it's got another processor. So this whole section at the end here is your programming interface, which is the equivalent of what's in one of these if you buy one of these for anywhere from $3 to $15 on Amazon, depending how you buy them. And so if you've got a board like this, you just go, when you start your project, says what kind of board do you have? You can say, oh, I've got an F4 Discovery board with this size of processor. And what it'll do, it pulls up a little on the side, it pulls up a little chip that looks like this, so you can see all the pins around it. And then on the left, it says, here's all your peripherals you have. So to set it up, you just go to the left and say, I need a UART, I need a CAN bus, I need 4 timers, whatever it is. You pick those, and as you pick them, then over on the picture over here on this side where it's got shows the pins on the side, the pins light up as you add things. So if I add a UART, it says, oh, here you're going to use this pin and this pin, and it might be like B2 and B3 or whatever they happen to be. So anyway, you go through and do that whole thing. And then there's another section that says about clocks. So there's a tab that says clocks. You go to that, and this big elaborate clock structure on the thing. You say, do I want to use external crystals, or do I want to use the internal crystal? And it's got all these multipliers and dividers and scalars. And so you have to go through and get all that. The main thing you have to do if you're going to run USB, by the time you're done, the USB clock has to be, I think it's either 24 megahertz or 48 megahertz. That's just a standard for that. So you have to play with all the numbers to get that to come out right. And then once you're done playing with that, there's a tab that says generate C code or something like that. So you click on that, and then it pops up and shows you the programming interface. So it looks like, at that point, it looks like an Arduino screen or something, where it's got all your code that is just generated. And then with the trouble, they've got multiple blocks inside of this. So it says, first of all, it says, at the top, it says, here's the license from ST Micro. And I usually just ignore the license. It just travels along with anything I write. And then it's got various sections that says something like user code 1, end user code 1. And then it says, here's a bunch of stuff they just stuck in. Here's another that says user code 2, end of user code 2. So what it does, it gives you a program. So at that point, if I compile that, it will do whatever's there, which at that point, all it's going to do is initialize all the peripherals that I just created in the first step. And then if you want it to do something, you go down, it says something about, user code 5 or something under it says, here's your infinite loop. It says like while one, and then that's where you would put your code. So if you want it to do something. So if I wanted to blink an LED, I could say, at that point, just like in an Arduino blink program, you just say, write this to this port to turn the LED on, do a delay, and then write this, turn it off, and do another delay, and just loop back. So that's what you do. It generates this whole thing for you. And it's kind of, it looks kind of big and kludgy when you're looking at it, with all these extra sections and stuff that you don't think you need. So you're tempted to rip all that stuff out. But at any point, I can just shut that down and go back to the setup tool and say, oh, I need to add 2 more UARTs, or I need to add 4 more pins for LEDs or for switches or whatever. So you just add the pins on and you say generate code. What it does, it takes the stuff that you had last time and adds the new peripherals into that. So you don't want to mess up that structure, because if you do, then that whole concept won't work anymore. So I can go back or right now I can go back and just pull it up and say, oh, I need to add, I needed to add some analog inputs. So I go to my peripherals and say, turn on the analog converter. And then I need to have this channel, this channel, this channel, if I want three inputs. And then I say build the code, and it goes back and there's all my existing code if I did it right. And then it just adds on the extra peripherals that I just added. So I just added the A to D converter on. So it'll be a setup routine for that. And then someone's going to define the pins. So basically that's the function of the processor itself. And then as far as writing code, you just go out and just write it in C code. It might have C++. I just use straight C when I do any of this stuff, unless I pull up somebody's example. And if it's in C++, I'll drop it in there. I can usually, merge this stuff together and get it to work. So basically you can go through and write your code, and then at any point you can go up the top and say build project, and it'll compile the whole thing and say, oh, here's some warnings, here's some errors, you forgot to put this in. Or I keep having a problem with the sign of a character. So I say define a buffer that's a character buffer that's going to be my USB output buffer. And then I go down, because I want to do an sprintf to take a handful of variables and put them into that character string. And then I go down, I call the thing, it says something like USB transmit or whatever it's called. And then it always comes back and complains, says, oh, well, your sign is incorrect. Here your buffer is defined as a signed character, because I just call it character. And then sprintf, I believe it's expecting to see signed characters, but then the transmit routine wants to see an unsigned character. So it just wants actual just bytes to do it. And I have to keep fighting with that to figure out how to get around and force it into convince it that's what I really wanted to do. So I have problems with that. But again, what I do is I go out on the internet and say, oh, I got ST Micro, and I want to say talk to the CAN bus, and you pull up somebody's example, and some of it is ST Micro will have tutorials or examples. You can pull up the code and use it, and you can find go to YouTube, and there's lots of people doing anything you're working on. Go to YouTube, and you can usually find somebody else that's trying to do this stuff. And so I just take a bunch of different examples and merge them all together to do what I'm trying to do. And so just incrementally, I'll test those out. So again, you go up the top under project as I build, and it comes back and says, oh, you forgot to include this, or this doesn't match here. And sometimes it's another day of trying to track the stuff down and why it won't work. So anyway, once you get that work, once it compiles, then I can go up the top and I can click a little thing that says either download, or sometimes I just click on what says debug, because there's something about the difference between downloading it and debugging it. You have to set it up differently. And if I get to the point where I get frustrated and can't get the download one figured out, I just go to debug, and it assumes you've got one of these plugged in, either one of these or this board just works directly. Plug in a USB port, and you tell it what your board is, and you say debug. And what it does, it takes your code. It'll compile it again if it needs to, just like Arduino does. But this one seems to be smarter than Arduino. Arduino seems to go compiling for a long time, even though it doesn't need to be changed. And this one, it's a fast enough compiler. You say, I want to debug. So it says, here, let me compile it. And it goes bang, bang. It says, okay, it's compiled with 0 errors. And then just shoves the code down to the board. And then it brings up here's your screen with all your C code on it. And it puts a line in there at main or wherever it'll run up to a point and then stop there. At that point, you can, if you want, you can single step, or you can say run. And if you just say run, it'll take off and run normally. Or you could stop it and go put breakpoint somewhere and say run, and then it'll stop at that breakpoint when it hits that. So that's handy to be able to do that over the way the Arduino stuff works. The Arduino stuff just lets you download code. If you want to do any debugging, you have to go in and do like print statements and say, at this point, what's this value? So you can print that out to see it. So this is a full debugger, like a full professional system. And various companies, like TI and I can't even think what the names of the companies. The companies keep buying each other out, so they keep changing. Like Freescale, I think is one of them. And anyway, whatever they are, this is a full professional system here. So I basically I can just go through and download stuff to the board, and once it's on the board, then I can just unplug it and then plug in the USB to get the power, and it hopefully does what I want it to do. So if I've got it, and like my current thing, I just explained that, I've got this board in the house right now. So if I want, I can plug this in and put my code on it, program it into that. And then what I can do is go out in the garage and pry off the other one that looks like this and put this board back on there. And that way I've got the code on my robot at that point. So that's kind of a kludgy thing that I'm doing, but that works out easier than dragging out my laptop that needs the external keyboard. And I have to use a mouse on it, and it would be nice to have an external display. I don't want to drag all that stuff out there and set it up. So that was just easier to do this. So that, so as Al pointed out, I think on the last meeting, or maybe we were talking about this privately, he looked at that IDE and said, it's too big and kludgy to figure out. And there is a learning curve to it. And I had to watch a lot of tutorials. And the thing was, I started out when I was working at Danfoss, I was handed one of these boards and said, here, figure out how to make this AI code run on this board. And the reason this board got selected is because the guy that was running our group was originally working in the microcontroller group on those controllers that they make. And they picked ST microprocessors. So that's how I ended up with this thing. And, over the years, I'm fairly happy that I'm going with this stuff. And previous to that, I was using a TI microcontroller. I don't have one handy here. Well, there's one in here. There's one in here, this red board right here. It's basically doing the same thing. It's got a Cortex M4 processor, and then it's got this end. It's got another processor to do the debugging stuff. So the TI stuff basically works the same way as the ST micro stuff does. So that they're just set up as professional development systems, and they both seem to work about the same way, and they both do seem to work. But after I switched over to ST micro, and it was nice because then on the ST micro, you can go on Amazon and buy a little board like this. It just has a processor soldered down to a board, and for very little money. So that'll get you going. So that basically, without pulling it up and showing you all this stuff, that's essentially, my workflow is I say create a new project, tell what processor it is, I pick my peripherals, and then do an initial compile, make sure everything's gonna work. And then I can put in code to say blink things, or in my case, read encoders, or I had to initialize the CAN bus, which wasn't real, or not CAN bus. I had to initialize the USB because you start with this and do it this way. You've just got the bare processor. You don't have anything. So if you want to use the USB, you have to, put in some code to talk to that, and you have to set up the clocks for, down at this end. I think there's 2 crystals on there. And one of them is like a 25 megahertz crystal, and there's a 32 kHz crystal. And it's nice that they give you both of those. So if you want to use them, you can. Or if you've got something that's not precise timing, you could just not use either crystal, and it's got some kind of built-in oscillator. They just say, I want to use the built-in one, and hopefully it's close enough in frequency to what you need to make your stuff work.
Nice.
And I don't know if it'd be worth me doing a video where I pull up my actual code and show that, because there's probably plenty of people out on YouTube, or just even if you go to the STM Micro site and look at their tutorials, they'll say, oh, here's how you do it. You load this code, and they'll bring it up and show you that stuff. um, it's not necessary. The problem I have with using people's tutorials is they never seem to do what I want to do. You'll say, well, here's the simplest thing in the world you could do. Well, I want to go beyond the simplest thing. I want it to actually work and work in the real world. So that's another problem that I have with that. But if you fight with it long enough, you can make basically any of these things, you can make them work. And the whole development system is completely free. It's just that you have to tell them up front. I don't remember if you have to create an account or just give them an email address. I ran across somebody else saying, "Oh, you could use this." And says, "Oh, but damn, they got an extortion code here. You can't just download it and run it like most of the stuff that you get." So he was complaining about that, and I complaining about it, but because then there's times when to download any software, you have to give them your information, and you want to download another piece of software, you have to give them your information again, and it just goes on like that. It gets aggravating trying to get this stuff. So I guess that's all I have to say about that for the moment.
Thanks for going through that. I find it interesting um, because it certainly looks powerful. On my side, let's see. Last we spoke, I was talking about a particular function inside of the ODOM, creating an ODOM statement from GPS and adding an IMU data in that process, because I'm running over uneven terrain and trying to use the IMU pitch and roll to update the physical location, all in an effort to improve the accuracy of sticking to the track. So I put the code in there and went out and ran a test, and I know it will shock you that the test didn't go the way that I wanted, and basically I'm getting this weaving. The blue pattern is actual, the red pattern is in this particular case, it's look ahead data, which effectively is the track it's supposed to be following. The X and Y axes is not the same, so you get sort of a wavy look ahead. I'm not exactly sure why that is. So anyway, where I'm at is I need to go debug why it's the performance is worse now. And I was looking at some of my other data elements in Plot Juggler, and I noticed my right wheel was reporting speed data seemingly correct, but my left wheel looks like it was providing data as I was sitting still. That's pretty consistent, and then it sort of died. So for some reason, it's like I have some sort of physical problem going on there. So, which could have been driving the bad behavior. But anyway, so the bottom line is in the field testing mode, trying to figure stuff out. Seems I've got a new problem here where my left wheel stopped providing data. I did want to share. This is a photo of what my electronics board looked like when I took off the blue tarp. And that is mouse poop. And I have a flippin' mouse who's living under my blue tarp on my board. So I share that jokingly, but previously I had an issue where one of my wires was eaten through. So I don't know that that's my issue, but I'll have to consider that as one of the options. Anyway, so that's my status. I think what I'll do is go back to this Python program that generates the odom statement from the GPS data and add some more, maybe a multi-array with before the adjustment and after the adjustment data, so I can, because right now I just save the odom statement. I don't save the intermittent data, so in order to be able to go back and debug that a little bit more. So just talking out loud helps me think through what I need to do there. First, figure out why my left speed died and if that's physical, and then maybe add some more debug statements to this particular Python program. That's where I'm at.
Back to your comments about your local animals, we'll call them, chewing on things. Juan had a story where he had his GPS up on top of his house. So he created a base station and he put his stuff up there, and he said either the birds or the squirrels were eating all of his wiring. And he said the reason is because modern plastics they use on for insulation on wire is made of like seed oils or something. And the animals just love that.
Oh
Hey,
my goodness.
that looks like food. So they start chewing on your wires, and they chewed through a lot of his wiring and made a real mess of it. I think he said it was birds that were picking on his stuff. So
Yeah, well, I don't know what sort of conduit how you would deal with that, but because our stuff is so small, you don't really make a conduit for that. I could put it in one of those what do they call them, NEMA containers. I mean, that's ultimately what I need to get to, is repackaging my electronics board so it's not laid out flat horizontally, but rather vertically inside a thing with a door on it that definitely isn't going to be chewed through.
it's a good thing you mentioned that you have animals on your stuff, because I just moved my robot out to my garage because they replaced my front door and put it on backwards, which makes it real hard to negotiate anything in front of my door there. So I decided just gonna be easier. I'll just move the thing out to my garage and park it out there. And now that I've got a brand new driveway that I should be able to drive in and out nice and smoothly. It had like a 1 inch step before with the old driveway and the concrete of the garage. But this thing, if I get just a slight forward motion, the thing would pop up over that. You could drive in and out of that. So I need to keep in mind that, yes, now that it's out in my garage, that there may be enough wildlife out there that I have to start worrying about something chewing on my stuff. So usually the stuff that's out there, I don't really care if it gets chewed up. But since this thing actually has, as you say, a lot of wires and a lot of sensitive stuff and a lot of expensive stuff, I don't really want anything chewing on it. So
Makes debugging a complete disaster.
one of my neighbors, the next duplex over, when that guy moved in, he had mice in his garage, because I think the previous people had the garage piled full of trash, and he had mice that were, I think, living underneath of the slab, and they'd run in and out. So he put up some kind of little poison traps that he built, and so he may have taken out enough of the mice in the neighborhood that I'm not gonna have as much problem with my stuff anymore. But that's something to keep track of.
Yeah, that's an option, isn't it? I didn't put down, I mean, in the barn, I've got tom traps, but I could put one right on my my robot.
And one of the problems with poisoning mice or rats or whatever is you got cats around, and they'll try to eat them, and that could be an issue too. So you have to think down the line and decide what's the right thing to do for that. So
That's all I got.
let's see, was there any more comments on animals eating stuff? I can't think of anything else right now. So I guess I'm done too.